All right, so this is a geometry video. This is Unit 1, Section 2, and we are talking about defining terms. So what we want to use, our objectives for this lesson, we want to take undefined terms, which were points, lines, and planes. So points, lines, and planes, okay, to precisely define certain things like parallel lines, perpendicular lines, ray, angle, arc, circle, and line segment. Okay, we want to actually have definitions for those. Okay, and the next one we want to do is we want to identify and name pairs of parallel lines, pair of perpendicular lines, a ray, an angle, an arc, a circle, and a line segment. Okay, so what we get here is we have this concept of lines. Okay, a series of points going in both directions forever. Well, we can break those up. We can break those into pairs of lines, which gives us parallel lines and perpendicular lines, or we have pieces of lines, which gives us rays and or segments. Okay, so here's what we've got. Okay, there's this question. It says, how are the undefinable concepts of point, line, and plane and distance used to define other mathematical concepts precisely? Okay, but we want to make sure that mathematical definitions must be precise in language, provide sufficient information, and include necessary information. Okay, so I'm going to go through and define some of these things. And so a ray, okay, the first thing I'm going to do is draw a picture. Okay, a ray A, B. Okay, so I have a point here A and a point here B. Okay, and I would say that this is part of a line segment, or part of a line with one endpoint that goes through another point. All right. If I were to name this, I would name a ray as ray AB, and I would put capital letters AB with a line going across it like that. Now, here's the thing. When we name it, and by the picture, okay, the A is the part that goes underneath that point, and the A is the part that goes underneath this point, okay? Let's say you had something like this. Let's say you have a different line, and I'm going to have it go in the opposite direction. I'm going to call this point D, call this point here C, and it goes in that direction. If I were to name this ray, okay, then I would have, I would name it as ray DC with the line going like that, okay? So your endpoint here is crucial, okay? That's how you name it, all right? The next one is a line segment. A line segment is part of a line that has endpoints. Okay, so an example of this, I would draw a line segment. Okay, it has dots on the end, and I would maybe call this line segment GH. Okay, if we were going to name this, then I would name it as GH with a line across it. Okay, no arrows. Or HG, okay? Order doesn't matter on line segments, okay? When you name it, order doesn't matter, okay? However, on a ray, when you name it, order matters, okay? And that's all I've got for those, okay? All right, on this next page, we've got, it's asking us, it gives us this diagram, and it wants us to identify the rays and line segments shown in the figure. Okay, so the first thing I'm going to do, I'm going to identify all the rays. Okay, and so what I want to look for is I want to look for an endpoint, okay, that goes through another point and then goes on forever. Okay, so the first one I see here is point C, goes through point D, and then goes on forever in one direction. Okay, so I would name this one as ray CD. Okay, so I would say ray CD, and I would put a line across it like that. All right. Similarly, I could start at point D and go through point E in one direction forever and ever. So I would call that ray DE. Okay? And then I also have ray DF. Okay? It starts at point D and goes on forever in one direction. So I would say ray DF, going like that. Okay? And that's pretty much it. Okay, you can't say that you can't start at point D and go through point C forever and ever and ever because that's an endpoint. Okay, it has to have an arrow on the other side. Okay, now if I wanted to describe the line segments, so line segments, then I would come in here, I have line segment ED. Okay, or you could write it as DE, doesn't matter. They mean the same thing. You could say line segment DF. Okay, so you could do FD or DF. Doesn't matter. You could have line segment DC, or you could have segment CD. Okay, either one, this one. All right. And then you could have line segment BA or AB. Okay. And I'm really just looking for, I know what the picture of a ray looks like. I just want to make sure that it has, I can find that picture somewhere on here. Okay. Now the other question is, you go, well, technically, could then you say that AC is a line segment? Well, there's nothing, you could technically connect those 2 points of the line, but based off the picture, I don't have anything there. Okay, nothing's connecting them. All right? All right, so take a look at the next one. It says, which statements are true? Check all that apply. Okay? It says that line XY, so here's line XY, contains ray OX and ray OY. Okay, that's true. Okay, here's XY. Okay, if I start at point O, I can go to the left and I have ray OX. If I start at O and go to the right, I have ray OY. This is true. Okay. It says that if I were to take line XY, this entire line, then it contains the segment YX, and yes, that is true, okay? I have this whole line here. I could just call this segment XY, and I have endpoints, so that is also true, okay? This says here that segment CA, line segment CA, and line segment AC are different segments. That is false. Okay, they are the same segment, okay, from one endpoint to the other and the distance in between, okay? It says that ray BA exists in the diagram. So you have B, and then you should have a line that goes through A and goes on forever in the other direction. That is false, okay? It would have to be ray AB. You could have ray AB. That could go on in that direction, okay? Then the next one says ray YX exists in the diagram. That is true. Okay, I could start at Y and go forever and ever and ever in one direction. Okay, so that exists. Okay, and then it says, how can we define mathematical terms, parallel lines and perpendicular lines? So what I want to talk about, parallel lines, these are lines that never intersect. Okay? They go side by side, side by side without touching. Okay, let me draw a picture of that. I would have something like this where I have a line going like this. Okay, and then I have a line going like this. Okay, and I'm going to call this line here, I'm going to call it AB. Okay, and I'm going to call this CD. Now what I would do to denote that they're parallel is I would put arrows. Okay, so arrows tell me they're parallel. Tell us they are parallel. Okay, and we could also say this. If we wanted to name these, okay, we would say that line AB, okay, and my line I would draw it like that with arrows, is parallel, okay, to line CD. All right, so when I draw this, this is the symbol for parallel. Okay? That's what parallel lines are. Okay? Perpendicular lines, okay? These are lines that intersect to form a 90-degree angle. Okay? We also call that a right angle. Okay, and so if I draw a picture of this, I'm going to have lines going like this. I'm going to put a little tiny square in the corner here. All right. That's a symbol. This symbol tells me that it's a 90-degree angle. All right. And if I were to put points on here, I'm going to call this B, C, D, E, F, and then G, H. Okay. And what I would say here, if I wanted to name these, then I would say that EF, line EF, is perpendicular to line GH. Okay, so this is the symbol for perpendicular. Okay, so a lot of this is just naming it and knowing what's what. Okay, so then it says, are there any parallel or perpendicular lines in the diagram? So let's go through here. Okay, so based off of our picture, okay, let's identify the parallel lines. Parallel lines. Okay, and that would be lines, and here's how I know. Those little arrows. Okay, if I take these two lines and I see that they have arrows on them, I know that they are parallel. Okay, so I can say this. I can say that that would be lines AB is parallel to CG. Okay, now I could go through here and I could say it, you know, or I could say lines BA parallel to GC. Okay, either way, it doesn't matter. All right, same thing. All right, now if I'm talking about perpendicular lines, all right, then the only one that I have, the only one that has this little mark right here is RS and CG. So I would say this. I would say line RS is perpendicular to CG. Okay? Or I could rewrite these because they're lines, not line segments, and I could say that SR, okay, is perpendicular to GC. All right, either way, doesn't matter. All right, that's what you've got.
What about RS and
We can't make that claim yet. But that's a good question. They are, technically, but we'd have to do what's called a proof. And we'll learn that in the next section, okay? Okay, on the next page, we have this little diagram here. So if we have points, we take this undefined term, we have these two defined terms called lines and circles, okay? And when we have lines, we can either talk about line segments, rays, parallel and perpendicular lines. But if we use the term rays, then we get this thing called an angle. Okay? And so how we define the mathematical terms of angle is two rays that share a common endpoint. Okay? And so here's what I draw. I draw something like this. All right? Two rays that share a common endpoint. So I'm going to put points there and like that. And I'm going to call this angle, I'm going to call this point A here. I'll call this point here B and point C. Okay? B, this point right here is called the vertex. Okay? The point that is shared. All right? And so an angle are two rays that share a common endpoint, okay? And what we want to do is we can measure how much these lines open up. Okay, so we can measure how much the lines, or the rays open up. Okay. And we would measure this in degrees. So measure in degrees. Okay. Now, if we wanted to name this angle, okay, then we would call this angle, put this little symbol for angle, and we would say A, B, C. Or we would name this as angle CBA. Notice how the vertex is always in the middle. Okay, the vertex. And that's how we name them. Okay. Now a circle, okay, let me draw a quick picture. Let me put a center. Do something like that. I'm going to put point, call this point P. All right. So a circle is a series of points equidistant to a center. Okay? And that's how we get a circle. All right? If I take point P to some other point out here, we'll call this, say, PR or something like that. And if I had P up here to, say, some other point PS, okay, I know that PS, and let me do segment PS and segment PR have the same length. Yes. Equidistant. Okay. All right. And if we named this circle, then we would name it as, and just use the symbol for circle, so a circle with a dot in the middle, circle P. Okay, where P is the center. All right. Yeah. Okay, on the next one, we're given this diagram here, and it says the angle created by ray OX and ray OZ is angle what? So we would call this angle, and I've got X, O, and Z. Okay, if I wanted to name this, I would name it as angle XOZ, or I could name it as ZO angle ZOX. Okay. On the next one, we've got two rays that create angle YOX. Okay. So let me highlight angle YOX. Oh, that was terrible. Come on. YOX, okay? You have ray OX, which is this ray here, okay? But you also have ray OY, would be the other one, okay? Because that one goes from here over, all right? And then the center of the circle is point O, okay? That's my center, all right? So your ability to identify points, lines, planes, rays, parallel lines, angles, all that stuff, okay? Okay, now on this next part, it says this thing about distance, and it says that distance is a concept that does not have a precise mathematical definition, okay? This distance depends on our unit of measure, okay? So let's say you have some distance here between -5 and 3.5, okay? That same distance would be different on this number line here, okay? So it depends on our unit of measure, okay? And we'll talk more about distance on a later date, okay? And then it says, can we define the distance around an arc or piece of a circle? Okay, and the answer is yes. Okay, if we were to take, an arc is just a portion of a circle. Okay, and it's measured by the angle it creates with the center. Okay, so let's just say that I took this point here, point A, and I called this point B. Okay, and what we have here is we have this arc, this distance from A to B. Okay, it's kind of like the crust of a pizza. All right. But if I wanted to talk about arc AB, okay, if I were to name this, then it would be, I would write A, B, and put an arc above it, like that. Now, the way we would measure it, okay, the measure of this arc, all right, if we were to take this and take this angle measure, okay, whatever this angle measure is, we'll talk about that in the next unit, then we would say that the measure of arc AB is equal to the angle measure of ACB. Okay, so if we measured this angle, then we could measure that arc in degrees. Okay, all right, I think that